All right. Moving on in section 1.6, the next other type of equation is what we call radical equations. These are, of course, not to be confused with awesome or tubular equations. These are just radical equations. And by radical equations, what we really mean are just equations with square roots, aka radicals. So the idea here, not to get too far ahead of ourselves, is if we have some sort of an equation with a square root, so in this case, the root of x plus 10 equals x minus 2 on the other side. How do we get rid of a square root? Well, the idea is you square it. You know, in some sense, our equation solving strategy is almost always based on a principle of just undo whatever math is there, right? You want to do the opposite of whatever the math is that's there to try to unpack it and sort of get as close as you can to just a single x. So for us, this means I can't really do anything with a root x plus 10. I can't distribute the root, right? It doesn't distribute over addition. I have to just square everything to get rid of it. So I do that. Let's do that. Square both sides. What happens to us here, right? The root of x plus 10, if I square it, square root, that's just going to give me x plus 10, right? Square a root, it just goes away. The x minus 2, so it's quantity squared, right? So it's not just that I'm saying x squared and then minus 2 squared. It's that whole quantity that gets squared. So that really is like a FOIL or a box multiply type problem, right? So if I do x minus 2 times x minus 2, if I do it as a box, that would be, right, x and x is x squared. I get a minus 2x and another minus 2x in the corners, and then I get this positive 4, right? Negative 2 times negative 2. Those terms all combined together would be x squared minus 4x and then plus 4. So the right-hand side of this equation is that, x squared minus 4x and then plus 4. So x plus 10 equals that. What we've done is we've essentially created, by squaring both sides, we've essentially created for ourselves a little quadratic equation. And so the move is going to be shift everything to one side and then try to factor it out to get to our answer. Which side should we shift everything to? Well, I would just move it, in this case, to the right-hand side so you keep the x squared term positive. So let's do a minus x and a minus 10, and we'll bring those two terms over. When we do that, right, combine like terms. So this is sort of minus 4x minus x is minus 5x, plus 4 minus 10 is minus 6. So I'm really looking at trying to factor 0 equals x squared minus 5x minus 6. This is our classic, ABC style factoring. And so, our a times c value here would be negative 6. The b value here would be negative 5. And so what's the pair that would make this happen, that would make this work? Well, that's going to be a negative 6 and a positive 1, right? Negative times positive is negative. And then a negative 6 plus a positive 1 would leave me with negative 5, would sort of make both of those things happen. Because the a value is 1, right? Just a single x squared with no numbers in front, I can essentially jump straight to the factored version directly using those two numbers. So minus 6 and positive 1, so the factor becomes x minus 6 and x plus 1. The whole thing is equal to 0. Now from there, I'm going to get, right, two different answers. I'll get x equals positive 6 and x equals negative 1. If we're sort of setting each of those to 0, right, you get sort of the opposite value as your solution, at which point you might say, I guess I'm done, we did it. But you have to check into the original equation. It's important to say that to yourself with an exclamation point to remind yourself how important it is. Check into the original. Sorry for yelling. So x is 6 and x equals negative 1. The reason we need to do a check, right, is because when we square both sides of the equation, a negative value squared is going to look the same as a positive value squared. So not to sound like a crazy person, but what happens here in some sense is when you square both sides, you lose the ability to tell the difference between positive and negative values, because once they're squared, they're both going to end up at a positive. So the original version of our equation, right, this root of x plus 10 equals x minus 2, that's really what we're trying to solve. It sort of becomes this other format that gives us these two answers. But if I do a check, I guess we'll just sort of, okay, something like that. So if I do x equals 6 back into the original, that's going to be the root of 6 plus 10 sort of equals question mark. 6 minus 2, right? The x's were in the places where we now have the 6's. That would be root of 16, which we're going to think of as 4, and then 6 minus 2 is also 4. So that seems totally fine. So x minus 6 is a legitimate solution, and we'll sort of include it. If I check -1, however, into the same equation, so -1 plus 10 under the root equals question mark, -1 minus 2, you can probably pretty quickly see the issue here, right? You're going to get a 9 under the root, which would be 3, but the right-hand side of your equation is a -3 instead, right? And so you're ending up at the same number, but you're ending up at positive and negative versions of the same number. Now, you don't necessarily have to be a PhD math student to realize that positive and -3 are not in fact the same number, and so this won't actually work as a solution. The idea, right, why is this even happening is because the version of this that we solved would be taking, essentially this step and squaring both sides, or maybe taking this step and squaring both sides. So you'd get a 9, and the -3 squared would also be 9. So if you squared both sides of the equation, you'd have something that's true. But back in the unsquared original version, they don't technically line up. And so, this is still kind of the best way we have to solve this. It just means you have this extra step where you have to check everything as a part of your final solution. In theory, sure, we should maybe always be checking our solutions and doing this kind of a thing. There's not really any reason not to, besides the fact that sometimes the numbers are bad. Even if your math professor is saying the numbers are bad, that's probably not a great sign. So that can happen. I'm not going to always ask you to sort of sub all of your different answers back into the original. But in this case, it's totally necessary. It's 100% necessary. And if you don't, you're going to get not necessarily the correct answer. There could be versions of this where both of the numbers work. There could be versions of this where neither of the numbers work. A lot of time what happens in the homework is sort of one works and one doesn't. Don't necessarily let that make you believe that that's always true. However, it is a relatively typical pattern. So if that's what happens to you, probably that's like how it's supposed to go. But always be on the lookout for the unexpected.